Okay, you guys, last lesson of Unit 11 / of this trimester, possibly. And it comes at you hard for DeMoivre's. I'm sure somebody that takes French would tell me I butchered that. Theorem. It's a shortcut for crazy, crazy, crazy problems. And here it is. It's right here. In other words, z to the n power equals this. Now, most of the time, it's to help you with problems like this that are like 1 plus I to the 10th power. Now, you're going to see that I have a couple of them right here, and maybe I'll start with these. So let's take a minute, teach this backwards, I guess. But here we go. In order to take something like this, which is just like this, and it gives us a little step-by-step instruction here. Use DeMoivre's theorem to find the indicated power of the complex number. Write your answer in both standard form and polar. So the question is, well, which one first? Well, you can see it's given to you in terms of polar, so you're going to do that first. Now, what are all these parts? Well, R is the length of my spinner, my modulus, my hypotenuse. What is N? Well, N, let's make some pretty colors here, is the power that they're going to throw at you. And notice it shows up here and here. Now, what in the world is this? Well, it's what we've been dealing. It's your argument. It's how far you spin your spinner to create that situation. What do you mean? Well, the first thing we're going to do is we're going to look at this and look at the 1 minus I standard form portion from inside here. We're going to ignore that 5. And we're going to take a look at what that would look like. 1 to the right, down 1. And what you notice is it's going to tell us a lot. So that's a 45, 45, 90. And if that's 1 and 1, this has to be the square root of 2, and you just found R. So R is the square root of 2, which we can put in that formula. So we got the square root of 2. We know what N is. N is 5. And then we get cosine of N, which is 5. I don't know why I put that. I guess it's true. Times. No, not times. Cosine of, oh boy. All right. Cosine of 5 times our argument. What's our argument? It's that. Well, if this is 45, this has to be 315, which is my argument. So that's 315. Now this gets a little weird, so hang in there. Plus I sine, and then we just repeat, because that's what the formula tells us to do. Now what are we going to do with this? Well, let's start with some algebra. Square root of 2, square root of 2, square root of 2, square root of 2, square root of 2. Every pair creates a 2, so that pair creates a 2, and then we got that square root of 2. So that part of it is 4 square root of 2. Now what in the world is that? Well, that's cosine. Let's get out our calculator. 5 times 315, 1575. And then we get plus I sine 1575. Now, it does say leave it in this form, but don't you ever forget that means this limitation is applying. Clearly, we've got something way too big. So we're going to just start taking off 360s until we get her done. So 1575, I had that right there. Whoops, not divided by. 1575 minus, let's start with 720, and then subtract 360, and then subtract 360. There's 135. So we're going to replace that with 4 square root of 2 times cosine of 135 plus I sine 135. Your book we'll probably have cosine of 3 pi over 4, because that's the same thing as 135, and then 3 pi all over 4. However, when it says put it in a plus bi form, I'm going to use this one because I'm going to spin my spinner 135, leaving me with a 45, 45, 90, where this is negative 1, 1, square root of 2. And I'm going to plug stuff in. So it's 4 square root of 2. Am I still on the screen? No. I'm sorry, you guys. That must be frustrating. So, 4 square root of 2 comes along for the ride. Bringing it here. Cosine of 135 is this picture. So, adjacent over hypotenuse plus I sine 135, which is opposite over hypotenuse. So 1I over the square root of 2. Now I'm not going to worry about getting these square root of 2's out of there, because look what happens. We distribute, these cancel. So I end up with negative 4, whoops, that's not 4I, plus, and then when I hit this, the square root of 2's cancel too, plus 4I. There it is. Okay, let's go to this one. So how do we get started? We look inside here. Now we're gonna need all this space. So we go 1 to the right and we go up the square root of 3. I hope you're sniffing this one out. That means this is 60, 90, 30, because it obeys the rules. So we can just instantly say that's 2. So we found our R, which goes right here. So here we go. 2. This one should be a lot easier. Cosine of 60 degrees plus I sine 60 degrees. And they might put pi over 3 in there, pi over 3, which is fine. We're done for the polar form part. But now here comes the a plus bi. So we're going to go 2 times cosine of 60 is 1/2 plus sine of 60 is the square root of 3 over 2. Where do I put the I? In front. Distribute, distribute, the 2's go, the 2's go. So I'd end up with 1 plus I square root of 3. Oh my goodness. What in the world did I just do? I made one little mistake. I hope I got in a hurry. So remember the formula, that's the problem. I didn't have the formula staring at me in the face. So remember it's R to the N. So when I got my R, I forgot to raise it to the 3rd power. So this is not a major deal, but it's kind of a big deal. So that just turns that into 2 cubed, which turns that into 8. And that would be my final answer. But down here, this is an 8, so it wouldn't be this. It'd be 4 plus 4I square root of 3. Glad I caught that. All right, so why did I do these first? Because this is the real value for DeMoivre. These problems that I skipped should be actually a little easier, but let's check it out. So when they're written like this, it looks a little bit more complex, but I want you to notice something. This is my R, making it pink. This is my N, making it green. This is my argument. So if we just take this crazy looking thing, rather than multiplying it all out by hand, we're going to plug her in. So we get the square root of 2. Won't forget this time, cubed. And then we're going to go cosine of n, which is 3. Uh-oh. Holy cow. You know what? I'm just going to own up. I'm not going to redo the video. I'm just going to own up. There was a little more wrong. Notice we have to go n times theta, n times theta. That's what I get for not having the formula sitting right in front of my face. So where am I? Oh, yeah. So I am so sorry, you guys. So here's the deal. This is all wrong. Owning your mistakes is good. So my n, I just totally forgot about that in the formula. That's supposed to slide up next to the 60. So it should have been 8 times, that's an 8, cosine of 60. So 3 times 60 plus I sine 3 times 60. Jeez, totally ignored that part of the formula, that part of the formula, and this part of the formula. Mistakes are made. So 8 times cosine of 180 plus I sine of 180, and we've seen this a lot, so we should just look at that and go sine of 180 is 0. So 0i, cosine is negative 1. So if we distributed it, then we get negative 8. All right, and here's my trigonometric form, which they'll probably put pi's in there. But oh well. All right, caught my mistake. Now let's move on to example 1. So we got 3, my n, times my argument, which looks like it's handmade for us, and then n times my argument. So what is this? Well, it's the square root of 2, square root of 2, square root of 2, which is 2 times the square root of 2. And now we can see that these 3's cancel, so we end up with cosine of 2 pi plus I sine, cancel, 2 pi. Now, does this fit into the argument limitations? Yes, it does. So we're good. We can keep it. But now we got to actually look at 360. There's 360. My opposite side, 0. That's 1. That's 1. So 2 square root of 2 times cosine of 2 pi, which is 360, 1 over 1, plus what's sine? 0. So distribute, I'd be left with 2 square root of 2, and that's it. But there's actually a 2 square root of 2 plus 0i. That's really what's going on. So here's the last problem of this entire trimester, probably. Same deal. Got our formula. Get out my colors. There's my R. There's my N. There's my theta, my argument. Now I just put things where they belong. So my R to my N, cosine of N times 5 pi over 6 plus I sine 4 times 5 pi over 6. I'm just following that formula. This is 256. This cross reduces. So I'm going to clean this up a little bit. Cosine of 10 pi over 3 plus I sine, same thing over here, 10 pi over 3. Now, are we done? Does this fit in this window? No, because this is like 3 1/3 pi. So we got to do something. What we're going to do, we could convert this. We really could. In fact, let's do that. Pi over 3 is 60. 60 times 10 is 600. So 256 cosine of 600 degrees plus I sine 600 degrees. Let's take away a 360. 256 cosine of 240. So we're subtracting 360 just to get it in this window. Plus I sine 240. Now, the book. They probably want that in radians. So pi over 3 is 60. 60 times 4 is 240, so we've got to multiply that by 4. So we're going to get cosine of 4 pi over 3 plus I sine 4 pi over 3. We're done with the trigonometric form. Problem is, they want it in a plus bi as well. So I'm only focusing on this right now. I'm spinning it 240. Be accurate, which means that's 60. Make it look 60. Come back. There's my 30. There's my 1. There's my negative square root of 3. There's my 2. Now we're ready. Almost done. 256. Cosine is adjacent over hypotenuse plus, what is sine? Opposite over hypotenuse. Negative square root of 3 over 2. Don't forget that little rascal of an I. Distribute, distribute. I get negative 128 minus 128i square root of 3. And there it is. That finishes this entire trimester, you guys. Incredible. All right. Well, I hope that made sense. If you love the video, even if you liked it, just like it. Like and subscribe. Make me famous. Thanks.